Hey, if you're working with data or even just trying to figure out what your company's data is and how the different tools fit in together, chances are that you've heard the names Databricks, Snowflake, DBT just thrown around like everyone knows what that actually means. But let's be real, if you're a little bit confused, you're not alone. These tools have become incredibly powerful, but also incredibly overlapping. On the surface, they all sound like they do the same thing. They manage data, process data, analyze data. But if you're curious enough to open the hood, you would understand that they were built for different reasons. And understanding those roots is very important because that's the key to making sense of what they are and how you can actually use them. In this video, we're going to walk through each of them one by one. We'll start with how each of the two got to where they are today, which problem originally tried to solve, and we'll kind of zoom out and look at how they fit together in a modern data stack. Let's get right into it. First, I'm going to start with the origin story because the origin story is important to understanding how these tools get to where they are today. First, I'll be starting with Databricks. Databricks was born out of a research project at UC Berkeley. The team behind it helped create Apache Spark, which was a huge breakthrough in distributed computing. What it does is that it lets you to process giant amounts of data across many machines in memory way faster than traditional methods like Hadoop. Then Databricks, the company, commercialized that research. It started as a platform to make Spark easy to use in the cloud. Its core mission was to handle big data and machine learning at scale, not just rows and columns, but massive logs, click streams, images, you name it. So from the beginning, Databricks was rooted in the data science and engineering side of the house. Now, when you jump to Snowflake, Snowflake came from a very different place. It was built by a couple of ex-Oracle engineers who wanted to reimagine the data warehouse for the cloud. What does that mean? You see, traditional data warehouses, think Teradata, Oracle, or even the early days of Redshift, they were hard to scale. You had to think about compute and storage as one unit. What Snowflake did is that they were able to split them apart. You could store your data once and run as many compute engines on top of it as you wanted without fighting for resources. This exactly was the reason why it caught the eyes of analysts and BI teams so quickly. It made SQL analytics fast, simple, and elastic. No managing infrastructure, just load your data and start querying your data. So if Databricks came from a big data and AI world, Snowflake came from the enterprise analytics world. But in all of this, you now have the third guy coming into the picture, and that is DBT. DBT plays a totally different role. DBT doesn't store your data or process huge logs, it lives in your transformation layer. DBT is essentially a tool that lets analysts write SQL to transform raw data into clean, analysis-ready models. And it brings software engineering best practices to analytics. Things like version control, testing, documentation, and modular SQL development. Just to be clear, it didn't try to replace your database. Instead, it said, hey, your warehouse is powerful. Let's treat it like a code base. And that mindset, that analytics in software sparked a whole new movement, and DBT became the backbone of that. I know you're somewhere thinking, if they are this simple, so why the confusion all the years? Why have people been saying different things? And why is it not so clear what these different tools do? The truth is, I just told you about the history, but here's where it gets a little bit tricky because if you go to Databricks website or Snowflake's or even DBT docs, you'll find that everyone is now trying to do everything. Databricks, which started as a tool for big data and machine learning, now offers SQL, dashboards, and even Lakehouse IQ, their AI assistant for business users. Now in Databricks, you can build reports directly in their notebooks. Now they even have SQL editor that looks a whole lot like something you would expect from a traditional BI tool. Meanwhile, Snowflake, which used to be just a data warehouse for SQL analysts, now Snowflake says it's a data cloud, a platform for Python machine learning, streaming unstructured data, and even application development. They now support Snowpark, which lets you run Python, Java, and Scala right from your warehouse. They've brought companies like Streamlit and Neeva to push into AI and developer tools. And DBT, on the other hand, have kind of diversified as well because DBT Labs has been expanding too. Originally, it was just a CLI tool for SQL modeling. Now there's DBT Cloud with scheduling, metadata, lineage, IDE integrations, semantic layer features, and even cross-platform compatibility. It works with Databricks, Snowflake, BigQuery, Redshift, you just name it. So yeah, it's not just you, the lines are seriously blurred in a way that they are all converging to one promise. And what is the promise? We are the platform for all your data needs, storage, transformation, analysis, AI, governance, the whole thing. And they're doing everything now. This may sound very great on paper, but in practice, it can make it really hard to figure out where to start or which tool should own which part of your data stack. But to help, I find it interesting to stop thinking of this in terms of feature checklist, because they all say they can do the same stuff. Instead, think about who each tool is speaking to. What kind of mindset does each tool actually support best? What we're going to do now is to kind of zoom out a little bit and see how these tools all fit together into the modern architecture. This is important because very often companies aren't just picking one, they're combining them. Here's one example I've seen quite a lot. As a first step, it's about the raw data being ingested. Your event logs, API data, or files land in the data lake, say AWS S3 or ADLS. Now, you use Databricks to process that raw data. It's great at handling JSON files, streaming data from Kafka, or running very complex transformation in Python or PySpark. Then, as a second step, is to now load this data into a warehouse. After some light cleaning or enrichment, that processed data gets pushed into Snowflake, where it's easier for the BI team to work with it. What Snowflake would do is to store it in a structured table with all the benefits of indexing, caching, and fast SQL performance. And typically the third step would be to transform and model the data. Then DBT steps in. It connects to Snowflake and transforms those raw or semi-clean tables into business-friendly models, like customer orders, active users within the last 30 days, or even your subscription metrics. And your first step would typically be the analytics and reporting. The dashboards are built on top of that, maybe Tableau, Power BI, Looker, or even Streamlit, which Snowflake now owns. What I've just described is a multi-tool stack, and it works because each piece is doing what it's good at. But there's a twist. In the real world, it doesn't work that way all the time. The stack doesn't always look like that anymore. Some teams keep the warehouse and keep everything in Databricks. Using Delta Lake as both their lake and warehouse, DBT can run there too, so why going somewhere else? Other teams just stick to Snowflake for everything, from ingesting via the Snowpipe to transformations with DBT or Snowpark to machine learning with Snowpark ML. And they just do everything because why live in a single platform if you can achieve everything in one place? So this is what it looks like in 2025. The architecture is more fluid. It's not about picking one tool or rejecting the rest. It's about building a setup that reflects your team's strength, your data shape, and your company's needs. Sometimes Snowflake is the star, sometimes it's Databricks. DBT often plays the role of stage manager, organizing the chaos, keeping the lines clean, making sure everyone is speaking the same language. To explain this even further, let's look at the underlying philosophies behind each of these tools, because it's going to really help you buttress the point and get more clarity around how to use it, when, and who this is designed for. Let's start with Databricks. Databricks is well optimized for data scientists and high-end data engineers. It's something that is built into the DNA and how it works. Databricks' philosophy is grounded in openness, flexibility, and advanced analytics. What they do is that they look at the entire data landscape and ask one question: why should you have to move your data into a rigid warehouse format just to do analytics? Why can't we have a single platform where raw data, SQL analytics, machine learning, and AI all live together? That's where their big idea, the Lakehouse, comes from. If you've heard about the Lakehouse combines the best part of data lakes, cheap, flexible storage, and data warehouse structured fast querying. So instead of having two separate systems, one for raw data and one for analysis, you get a unified system with one copy of data and many ways to work with it. At the core, Databricks believes that data teams should work with software teams with notebooks, version control, and open file format like Parquet and Delta Lake. They've leaned so hard into open source tools, Spark, MLflow, Delta Lake, and now even AI models with Mosaic ML. So if you're someone who values control, customization, and the power to build complex things, Databricks is built for you. But that flexibility can come with complexity if you're an SQL first user who just wants to answer business questions really quickly. Databricks might feel a bit heavy or too technical at first, and that's the trade-off. Snowflake, on the other hand, is managed, elegant, and built for scale. Snowflake takes almost the opposite approach. Their core philosophy is, let us handle the complexity, you just focus on your data. From day one, Snowflake has been obsessed with simplicity, performance, and governance. It's not about giving you every possible control. It's about giving you confidence that this platform you've chosen is just going to work. What it means is you don't have to tune your cluster, you don't have to manage infrastructure, you don't have to think about caching or partitions. Snowflake figures that out for you behind the scenes. This comes with their warehouse route. But as they've grown, their vision has expanded. Now you talk about the data cloud, a connected ecosystem where data from different sources, clouds, even companies can be securely shared and analyzed. What Snowflake is saying is your data shouldn't live in silos, it should be discoverable, shareable, and governed at scale. Snowflake is building toward a world where your data, your apps, your models, even your AI agents all live inside Snowflake's walled garden. Not because you can't do those things elsewhere, but because here, it's fast, clean, and secure. If you value ease of use, centralized governance, and SQL as the universal language of analytics, Snowflake feels like home. But the trade-off is you're more dependent on Snowflake's ecosystem. You don't get as much access to the internals, and you're less likely to build custom pipelines or experiment with bleeding edge ML. But when you now come to DBT, you are talking about structured, transparent, and built for collaboration. The philosophy of DBT is quietly radical. DBT came from a common frustration we all have, and is simply most data work is messy. SQL scripts live in someone's laptop. You know what that feels like. Models are undocumented, dashboards break, and no one knows why. Metrics don't match across teams, so DBT asks, what if we treated data transformations like real software? That's the core idea. Bring engineering discipline to analytics. Write modular SQL, version it in Git, add tests, add documentation, track lineage, deploy it automatically, know where every column is coming from. DBT doesn't replace your warehouse, so you get it right. It tries to organize your warehouse. It doesn't care whether you are on Snowflake, Databricks, or BigQuery. It's platform agnostic. But the real power of DBT is cultural. It bridges two worlds, where you have the analysts who are close to the business questions but often lacking engineering tooling. And you also have the engineers who know how to build reliable systems but aren't always close to the metrics. DBT created a new kind of role, and that is the analytics engineers, who live in this middle ground and bring both perspectives together. If you value clarity, collaboration, and trust in your data models, DBT is your guiding light. It doesn't care how flashy the dashboard is. All it wants is the logic underneath the dashboard to be rock solid. But what's the trade-off? DBT is not designed for everything. It assumes SQL is the transformation language. It's not for unstructured data or training models or building apps. It's opinionated, but in the best way. So here you have it, 3 philosophies, 1 data stack. So when you line them up side by side, Databricks is built for flexibility, scale, and deep data engineering. It wants to unify your lakes and warehouses into Lakehouse and empower your data scientists with power tools. Snowflake is built for simplicity, performance, and enterprise readiness. It wants to be your all-in-one data platform where analytics, AI, and apps live under one roof. And DBT is built for structure, transparency, and collaboration. It wants to make your data models clean, reliable, shareable, no matter where the data lives. But you might be asking, what's the takeaway from all of this? And it's simple. You don't need to master all 3 tools at once. Start from where you are and what problem you're trying to solve. Ask yourself, am I trying to clean up SQL logic and build trustworthy data models for my company's reporting? Well, you could start with DBT. But if the question is, am I trying to store and query large volumes of structured data reliably, quickly, with minimal setup, you could start with Snowflake. But if your question is, am I dealing with complex data pipelines, streaming data, or training ML models on a huge data set, well, you could start with Databricks. Once you've gotten this solid base in one, you will naturally bump into the others. These tools aren't rivals, they are neighbors. Learn the one that fits your current role best and grow from there. You want to try them? I'll leave a link to them in the description. As a final word, I'm just going to say these tools aren't just changing how we work with data, they're changing how we think about data teams, collaboration, and ownership. From all we've seen all over the world, we know that the future of data isn't just one platform to rule them all. It's about composable systems that fit your team's unique needs. So don't feel pressure to learn everything just at once. Just ask, what problem am I trying to solve? Then pick the tool that helps you solve that problem today. The rest will naturally follow, just like everything does. Well, it's a wrap from here, and thank you for watching to the end. I'm going to be seeing you in the next one. Please like and subscribe so others can have access to these and to encourage me to do more of these videos. I'm going to be seeing you in the next video. Bye for now. Cheers.